Alright, so we have our video here for 5-2. So 5-2 here is the idea of prime factorization. And what we're going to do here is we're going to take what we know about factoring numbers out, and we're going to try to break it down to a really basic level. So we have two new vocabulary words. We have the word prime, and it's basically a prime number is any number whose only factors are 1 and itself. So an example of that would be 17. The only factors of 17 are 1 and 17. All right, a composite number is a number who has more factors than just 1 in itself. So a example would be 8, who has 1 times 8, 2 times 4, and that's a composite number. All right, so get those copied down. Here are your examples that you can copy down as you're finishing that definition. All right, so then the list, we want to get a list of prime numbers because we want to factor the numbers out to the prime number level. I'm going to show you what that means here, but copy down this list of prime numbers so that way we have it for our first example here. Alright, so we are going to take a number that should be really easy for us to factor, and we're going to factor it out. So we have the number 12, and we're going to really, when we get the prime factorization, it's going to look a lot like the factor trees if you've ever had those before. So what I'm going to do is I'm going to try to break down the factoring of 12 to where the only numbers that I have listed as factors are these prime numbers. Now, obviously there's more prime numbers, 13, 17, 19, 23, 29. Those are all prime numbers too, but I don't think we'll deal with any numbers that have us dealing with that per se. So what I want to do is I want to list the factors of 12. So I would say,
okay, Seth, just to clarify too.
So if we are factoring 12, I'm going to use, I can use a variety of factors here, and I'll do this a couple different times to show you that it all turns out to be the same. But with 12, I would say 3 times 4. Well then, let me erase this because that overlapped, sorry. Okay, so 3 times 4, and now notice I have a prime number here in 3, but 4 isn't a prime number. 4 is composite, so what I can do is I can turn it into 3 times 2 times 2. Because 3 times 2 is 6, times 2 is 12. So then what my job is to do is to list them in order. So 2 times 2 times 3. So I just rewrote this in that step. And then the last step is I want to try to combine them into exponents. So what do you see in here that I can use as an exponent? Yep, 2 times 2 is 2 squared times 3. So 2 squared times 3 is 12. Well, let's do this in a different color and start with a different factor pair. So if I do 12 and I do 2 times 6, well then what I want to do is I keep 2 by itself because it's a prime number I can't factor 2 anymore. So 2 times, I can factor 6 and turn 6 into 2 times 3. So as you see here, I have the exact same idea from the first one. Now I want to take an exponent, use exponents whenever I can. So 2 squared times 3. The one rule that you always want to do is you want to list the numbers in order. So that's why when I did that in this step here, I want to list them in order. A great way to go about that is to always start with the lower number over here. Always doesn't work out, but in the end you have to list shorter or the lowest number on the left going left to right. Alright, so let's again do the prime factorization of the number 30. Okay? So for 30 here, I can do a lot of different types of factor pairs, but the factor pair I'm going to use, I'm going to use 3 times 10. The reason I'm using 3 times 10 is because I know 3 is a prime number, so I already have it broken down a little bit. So when I see 3 times 10, I know that I can factor 3 times 10 into 3 times 2 times 5. And then I know that 2, 3, and 5 are all prime numbers, so I cannot factor that anymore, but what I need to do is write them in order of least to greatest, so 2 times 3 times 5. And my check, if I wanted to do that, is I could do 2 times 3, which is 6 times 5, moving left to right like my order of operations would tell me. 6 times 5 is 30, so I know that it works. Okay? So the idea here is that I want to get a long list of prime numbers multiplied by each other to get my total number. So let's try 72 here. All right. Should be a little bit bigger number, but it should be pretty easy for us to manipulate. So if I use the factors, and again, you can start with any factors that you want. This example is in your book on page 124. They give you two different examples. I'm going to do a different example so that way you can compare this to those two, so that way you can see a different way to do it. And you have three different examples. So 72, I can find 72 by 8 times 9. Neither one of those are prime, so I have to break and factor all of those. So the 8 turns into 2 times 4, and 9 turns into 3 times 3. Well, as I look here, 2 is prime, 3 is prime, 3 is prime. The only thing I have left to factor out is my 4. So 4 is 2 times 2. So 2, the prime numbers all come down 2 times 2 times 2 times 3 times 3. Well, now that I have this broken down, I see that I can get these numbers combined as an exponent. So 2 times 2 times 2 is the same as 2 to the third power times 3 times 3 is the same as 3 to the second power. So my prime factorization of 72 is 2 to the third times 3 squared. What you should do is, again, look at page 124. See, they use different factor pairs to start and combine that. So those are a few examples we've done together. We're going to do one more together before I give you 2 or 3 to do on your own. Alright, so we are going to do 148. Alright, and this one is we multiply 2 times 74 to get that. Then I know 2 is going to carry down, so 2 times, and then 74 breaks down to 2 times, well, I don't know what 74 divided by 2 is, so I'm going to do that off to the side. 74 on the outside, or inside 2, 3, 6, 1, 4, 37. So 2 times 2 times 37. And then I go through my list and I find out that 37 is a prime number. So I do 2 squared, because 2 times 2, times 37 is the prime factorization of 148. Alright. So, as you did those with me, I'm going to give you 2 to do on your own, then you can check them with me here in a minute. Let's do 600. Alright, so pause the video, try this one on your own, and then check it in a second when you're done. Alright, so as you get started here, 600, I would just do 6 times 100. And again, there's a ton of different factor pairs you could use there. 6 times 100 works. Okay, then I break that down into 6 is 2 times 3, and 100 I can break down into 4 times 25. I could have done 10 times 10. Again, as you're breaking these factors down, it should always turn out to be the same thing. Well, 2, 3, and 4 are all prime, so I can carry those down. And then 25 is the same as 5 times 5. Now, as I have, 4 is not prime, so I can change that. My apologies. And I need to erase this and adjust that. Sorry about that. So, 2 times 3 times 2 times 2 times 5 times 5. Again, all my 2's, I have 2 to the third, so I have 1, 2, 3 2's times 1, 3 times 1, 2, 5's, 5 squared. So 600 is the same as 2 to the third times 3 times 5 squared. Alright, and the last one we're going to do together is 363. Alright, so again, I can do 3 here times 121. Well, I have to go and think about it. And again, this is a challenge one because you're supposed to know that 121 is the same as 11 times 11. So I have 3 times 11 times 11. I know 11 are prime numbers. So 3 times 11 squared is 363. Alright, so don't forget to check your assignment for the page, the worksheet page, and the bookwork. The bookwork is on pages 124 and 125. And good luck.